Good morning, Veritas. This is a video for the lesson on April 8th. It is Wednesday. This video is for April 8th. So let's get right into it. These are the problems that we had from yesterday I wanted you to try on Tuesday. So get this out. Pause this if you need to. Just in case we run out of time on my video, here are the ones I'd like you to try today when we are done going over these ones. Okay, so pause here, and these are the problems I'd like you to try after we go over this today. And we will go over these ones in tomorrow's video. All right, so let's start right here with today's, Tuesday. This was from April 6th, if you go on the Google Classroom and look for that lesson. Okay, my phone is about to die, that's why I have it plugged in today. Okay, so fractions, mixed numbers, day 5. So I'm going to give myself an entire sheet of workspace. I'm going to start with just one problem here. So there's an A, a B, and a C. So I'm just going to start with A. I don't know how long it's going to take. So it says to compare the following fractions using the correct symbol. So less than, greater than, or equal to, we're going to put into these circles. Okay? But we got to be real careful to make sure that we have them correct, okay? Because you won't get any credit for number 1 if any of these are wrong. So these ones where you have to do more than one, you have to be extra careful, because if you do such good work on 2 of them and then get the 3rd one wrong, you get 0 points. So we got to be real careful with these, okay? So part A is 3/8 or 3/4. We're comparing them using these symbols. Which one is greater or less? Okay, so I noticed that they have different denominators, so we could turn the denominators into the same number. We could turn this 4 into 8. That's one way that we could do it. Another strategy that in this case is going to be easier because they already have the same numerator. So when fractions have like numerators, when they are the same, then you can just look at the denominator because those are the size of the pieces. So you have 3 pieces that are 1/8 in size. This one you have 3 pieces, so the same number of pieces as here, but they are 1/4 in size, okay? So if we draw a little model of 1/4, 3/4 is going to be this much, 3 out of 4, okay? 3/8 is going to be the same size whole, but cut into 8 pieces. 3 of those, each piece, if it's an 1/8, is much smaller because it's the same size whole cut into more pieces. So there's 3/8. So it's obvious that 3/4 is a lot bigger. So a way that we can tell that when they have like numerators, when the numerators are the same number, 3 in this one, you look at the denominator, because the denominator tells you the size of the pieces or the total number of pieces in each whole. So if there's 4 pieces in each whole, those pieces are going to be bigger than if there are 8 pieces in the same whole. Those pieces are going to have to be smaller, okay? So the bigger the denominator, the smaller the pieces are going to be. The smaller the denominator, the bigger the pieces are going to be. So since we have 3 of these pieces and 3 of these pieces, the smaller number has bigger pieces. So 3/4 is greater than 3/8, and the way this is written, 3/8 is less than 3/4. Okay? 3/4 is more. So we got to make sure we use the symbol that is showing that this one is more. So this one is less than this one. Okay? Good job if you got that right. We could have turned this into 1/8 like we've been doing. Turn the denominators into the same number, so we can turn this one into 8. 4 times 2 is 8, so 3 times 2 is 6/8. And all we did was multiply 3/4 times 2/2, which equals 1. We've been doing this a lot. So now we have 3/8 or 6/8. 6/8 is more than 3/8. So there's 2 different strategies, but it would have been easier to just, since the numerators are already the same, it would have been easier to just look there. Okay, let's go to B. So I'm going to make some space for B. Plenty of room here. It says 2/8 or 4/9. Which one is greater or less than the other? So we have 2/8 and 4/9. We could make the denominators the same, but we're going to have to multiply all the way up to 72 in order to do that. So notice that, again, the numerators this time, again, would be easier to change. So we have 2/8 or 4/9. So we're going to change 2/8 into a numerator with a 4. That way they both have a numerator of 4. And then we can do the same thing we did here. Look at the size of the denominator, and the smaller the denominator, the bigger the pieces are. Okay, so we're going to turn this into a numerator that's 4 because 2 easily multiplies to get to 4. So 2 times 2 got us to 4, so we have to multiply the denominator times 2 as well. That way we really multiplied by 2 halves, or 2 over 2, which is equal to 1. So we didn't really change it. So 2 times 2 is 4, and 8 times 2 is 16. So now we have 2/8 is 4/16. Okay, so we have 4 and 4 as our numerators. So 4/16 size pieces, or 4/9 size pieces, since the bigger the denominator, the smaller the pieces, and we have 4 of these smaller pieces, we know that this fraction is smaller than this one. Ninths are bigger because the smaller the denominator, the bigger the pieces are, just like we talked about here. The smaller the denominator, the bigger the pieces. The bigger the denominator, the smaller the pieces. Okay? Bigger denominator, smaller pieces. So since we have 4 of those pieces and we have 4 of these pieces, the bigger pieces are going to be bigger. So 2/8 is less than 4/9. Give yourself some snaps if you got that. Very nice job. You could definitely just turn the denominators into the same number and do it that way. That might be a little harder in this case because 2 can easily multiply to get to 4. So always look at both the numerators and the denominators and see which one's going to be an easier way to solve it. Okay, for this one we have 5/12 or we have 9/16. Okay, so we could turn both numerators into 45. We could do that. Then look at the size of the pieces. I don't know, 12 and 16, that's going to be kind of hard. I think those will both multiply to get to 48. They will, so we could make the denominators 48. We could definitely do that and then compare which one's bigger. But here's the way I want you to think about it today. So this is 5/12. 6/12 is half, right? 1/2 equals 6/12. Because if you do 2 times 6, you get 12. And if you do 1 times 6, you get 6. So 6/12 would be equal to half. So 5/12 is less than half. Because 6/12 is half. So 5/12 is less than that. So it is less than half. Now let's look at this one. 9/16. 8/16. If we simplify this, divided them both by 8, we get 1/2. So 8/16 and 1/2, 2 times 8 is 16, 1 times 8 is 8. So these are equivalent fractions. So if 8/16 is half, that means 9/16 is more than half. So we're using our benchmarks of what is 1/2 to help us solve this one. So 6/12 is half, so 5/12 is less than half. 8/16 is half, so 9/16 is more than half. So if this one's less than half and this one's more than half, then look at that. That one is greater. So 5/12 is less than 9/16. So all of these happen to be less than today. But don't let that trick you. If they're all less than and you did the work to put in the work to solve it, then that's it. Don't get caught up in what's the pattern, right? All of them can't be the same because they can. All right. You just got to be careful that you showed the work. Look at how much work we did here for those 3 parts. And I really like the way of thinking here. So I'm going to give you one similar to that for you to try next time. All right. Number 2, let me give myself plenty of space. I'm going to flip right over to the new side because that one took us a lot of room. Number 2, it says subtract 9 1/3. We're subtracting 7 3/4. 7 3/4. 9 1/3, 7 3/4. Making sure I got the right numbers. We are subtracting. Okay? So again, our denominators are not the same. We have got to make those denominators the same. So we can turn 4 multiplies to get to 12, and 3 also multiplies to get to 12. If we count by 3s, you can just add 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 can get to 12. If we count by 4s, just add 4 more. 5, 6, 7, 8, 9, 10, 11, 12. So since both of those, 3 and 4, can multiply to get to 12, then 12 can be our denominator. So 4 times 3 got us to 12. So we have to multiply the numerator times the same number, times 3. 3 times 3 is 9. So 3/4 and 9/12 are equivalent. They're the same thing, same value. Now, 3 times what got us to 12? 1, 2, 3, 4. 3 times 4 was 12. So we're going to do 1 times the same number. 1 times 4 is 4/12. Okay, if we had 4 one time, we have 4. Okay, now's actually where the tricky part comes. So now we do have denominators that are common. They are like denominators. We can now subtract. But we have 4/12 minus 9/12. If I only have 4/12, I can't take 9/12 away. So we gotta borrow from the whole number. So we're gonna borrow from this 9. We're just gonna trade 1 whole from the whole numbers, and we're gonna give 1 whole to the fractional amount here. So we're just trading 1 for 1. So we didn't really change it. We're just doing it. We're making some changes here so that we can do the subtraction. So we'll take 1 from the 9, make it 8, and we're going to add 1 to the fraction. So how many 12ths is equal to 1? 12. In order to have the whole thing colored in out of 12 pieces, you need all 12 of them colored in. 12 12ths is equal to 1. So we just took 1 from here and added 1 to here. Now 4 plus 12 is 16 12ths. Okay, so as a fraction, we just put these parts together. This was 1, so we took 1 from here and added 1 to here, and now we have 16 12ths. Now we can subtract. 8 minus 7 is 1. Then we have 16 12ths minus 9 12ths. Since the denominators are the same, we're going to keep it the same, and you do 16 minus 9 is 7. So the answer here is 1 and 7 12ths. So that is our answer, 1 and 7 12ths. I'm pretty confident that I did that right, but I'm still going to check it quickly. If you take, we did subtraction, this minus this equals this. That means this plus this is going to get us back to 9 1/3. So even though it's going to take me an extra minute, I am going to check it with addition. Okay, 4ths can become 12ths. 4 times 3 was 12. So 3 times 3 is 9 12ths. 7 plus 1 made our 8. 12ths plus 12ths are 12ths. 7 plus 9 is 16. And now we have 8 plus, this is an improper fraction. So we just have to change this into a mixed number. So we're dividing. This is 16 divided by 12. Okay, so if I have 16 of something and I'm making 12 groups, or I'm making groups of 12, you can only make one group because 12 times 2 is 24, and we only have 16. So I can only make one group. 1 times 12 is 12, and we have 4 left. So since there's no more numbers here to bring down, 4 is our numerator. There's 4 left out of a total. Our divisor is 12. So we can write that as 1 and 4 12ths. So 16 12ths is 1 and 4 12ths. Plus the 8 wholes makes 9 and 4 12ths. And if we simplify 4 and 12, we can divide them both by 4. We still have 9 wholes, but 4 divided by 4 is 1, and 12 divided by 4 is 3. And we end up back to 9 1/3, which is where we started with this problem. So we know that our subtraction was correct. We didn't mess up with this borrowing because that is tricky stuff. We got the answer right. And this just took another couple of minutes. I know that this is tricky here. My class should be doing pretty good with this, but I am aware that this is complicated, so we're going to do more of this division soon. Okay? But basically 12 goes into 16 only one time without going over, and then there's 4 more to get to 16. Right, 12, 13, 14, 15, 16. So 4 is our numerator, and our denominator stays as 12. Okay, add those together, you get 9 1/3. Okay, give yourself some snaps. That was tough. The borrowing is tricky. So keep practicing with that, and just be more careful when you get to here. If you got that wrong, you probably didn't notice that you could not subtract here. So you got to be a little bit more careful. Ooh, I have 4 minus 9. I can't do that. All right, last one. Number 3, it says compute. That's just a fancy way of saying solve this problem. We have 5/8 times 2/3. 5/8 times 2/3. 5/8 times 2/3. Just making sure I have it right. We learned last week about multiplying fractions. They're a lot easier than adding or subtracting fractions. You see how hard this was? When we multiply fractions, you just multiply the numerators. 5 times 2 is 10. You multiply the denominators. 8 times 3 is 24. Then you simplify. These are both even numbers, so we can divide them both by 2. 10 divided by 2 is 5, because 5 times 2 is 10. And 24 divided by 2 is 12, because 12 times 2 is 24. So the answer to this problem is 5/12. So if you got 10/24, great job. You got to just look one more time and say, can I simplify that? Can I make those numbers any simpler to show the same value as an equivalent fraction? And the answer is 5/12. And that's it. Okay, give yourself some snaps. Those were tough problems today, and you guys deserve tough problems. So I'm going to keep giving you some tough ones. We're going to keep working through them, and let me know if you have any trouble. Okay, some kids have been struggling with some of these. Some kids are doing amazing. Everybody who's trying is doing amazing, but some kids are struggling, and I think the biggest thing is you need to just slow down, give yourself a quiet space to work, and check if you did your math right. All right? So check these ones carefully. Good luck, and we will go over these tomorrow. All right. Everybody have a great day. See ya.